Hi, welcome to a new video. Today we are going to discuss about the deletion in linked list. This is a list of elements that we have that we are having in the list 10, 20, 30, 40 and 50. The head address is 100. The first address that is represented by the variable head. First element is represented by the variable head and its address is 100. So we are going to delete the element. First step of deletion is to verify whether the list is empty. How to verify? If head equal to null, then printf list is empty. Else, if this case is false, that means some elements are there. Then we are going to we have three options. First one, deletion from the beginning, deletion from the last, deletion in between two elements. First one, deletion from the beginning. Here, deletion from the beginning in the sense the first element that we are going to delete. So in this case, if we are deleting this element, what will be the next first element? 20 will be the first element. So what we are going to do is we will assign the value of a head to head tends to next. Simply that we can say like that. So I am going to write a program for this. If POS equal to 1, that is if position equal to 1, then we are going to delete the first element. So what I am doing is I am assigning the head variable to a temporary variable q, head equal to q. That I will tell why I am doing like this. Okay. Next step is what? I am going to assign the head value to the next element. So head equal to head tends to next. Okay. Now the value of the address of head is reassigned as 200. So the address is reassigned as 200, but still the link remains there. So what I am doing is q tends to next equal to null. I am assigning the address of the previous head node as null with the help of a temporary variable q. Okay. After that, I have to clear this memory 100. I have to clear the memory. For that, we have a function named free of q. So once we completed free of q, then that memory will be released. The memory 100 will be released, and that means this node is completely deleted. And this address also cleared. Okay. After that, I am decrementing the value of count minus. Very simple. So deletion from the beginning is over. Next, deletion from the last. Okay. For example, I am using the same. Okay. I am using the same link here for doing the operation. Okay, right now the address is 100. Next, deletion from the last. Okay, how will we verify whether the user opted the last element? For that, I am writing a condition for that. If POS equal to CND, if so, then we can go for the deleting the last element. How will we do that? First step is to move from q to the previous element, the previous not the last element. We have to move to the previous element. Then we have to do the operation. That means once we reached at 40, from 40 we can do the operation. So how will we do that? Remember, we have to free this one also, this memory also. We have to delete this one also, as well as we have to reassign not reassign. We have to make the address field of 40 as null. So these are the work that we have. So if position equal to count, that means user opted the last position. If so, then we are going to write a program for that. Q equal to head. I am assigning the value of q as the head node, and we are going to travel from first element to the last element. Not the last element, the previous element, second last element. Okay, so while q tends to next not equal to null. Okay, this is not the correct option, because if we are traveling with the condition q tends to next not equal to null, then it will move to the last element. Okay, I will explain. If we are writing a condition like this, then what will happen? Okay, if while q tends to next, so q equal to q tends to next. Okay, initially q equal to 100, 100 tends to next, that is what, so here is 200. So 100 tends to next is what? 200. 200 not equal to null, the condition is true, so q equal to q tends to next. So q is reassigned as, so q equal to, initially q equal to 100, after the insertion after the condition gets true, it is reassigned as 200. Again 200 tends to next, that is 300. 300 not equal to null, condition true. If so, q equal to 300. Then 300 tends to next, that is 400 not equal to null, if the condition is true, then q equal to 400. Then 400 tends to next, that is 500. 500 not equal to null, condition true. If so, q equal to 500. q equal to q tends to next, so q equal to 500. That means q reaches the last position. Then again 500 tends to next, that is what? Null. Null not equal to null, condition false. That means q reaches the last position. Once we reach the last position, we can't do anything, because we can't travel in the reverse direction. Once we reach the last position, then that's it. You can't move on to the previous, or you can't access the previous element. So this is a problem here. So what I am going to do is, I am modifying the condition of this traversal. Q tends to next not equal to null. So let me check. Q equal to 100. 100 tends to next is what? 100 tends to next is 200. Again 200 tends to next. So you can write simply like this. 100 tends to next is 200. 200 tends to next, what is that? 200 tends to next 300. That means 300 not equal to null. So if this is a condition, then q is reassigned as q equal to q tends to next. Again, now q is in the second position. Now we again verifying 200 tends to next. What is that? 200 tends to next is 300. Okay, 300. Again 300 tends to next. 300 tends to next is what? 400. So 400 not equal to null. The condition is true. If so, q equal to q tends to next. Q equal to 200 tends to next is what? 300. So q equal to 300. Again 300 tends to next is what? 300 tends to next is what? 400. Okay, and that 400 tends to next. 400 tends to next is what? 400 tends to next is 500. 500 not equal to null. Okay, condition true. If so, q equal to 400. That means q equal to 300 tends to next, that is 400. Again I am going to again check, because q equal to 400 now. 400 tends to next, what is that? 400 tends to next 500. 500 tends to next. 500 tends to next, that is null. Okay, in this case the condition is false. That means we reach the second last position. Once we reached here, then our remaining works are very simple. Okay, q is now in the second last position. So what we are going to do is using a temporary variable p, because p and q are now free for all the operations. For insertion, p is dedicatedly used for creating a new node, but in this case there is no point of creating a new node because this is deletion. So what I am doing is I am using p for temporary operations. Okay, p equal to q tends to next. P equal to q tends to next. So now what is the value of p? P equal to 400 tends to next, that is 500. Now I am assigning the value of q tends to next, that is 400 tends to next should be null. Okay, so q tends to next equal to null. So what's the value of this one? This is null. That means this connection get lost, and this 500 is in the variable p. Now free of p, completed. Okay, then count decremented by 1. Okay, next deletion between two elements. Okay, now this element is deleted. So okay, again position is collected and verify if POS greater than 1 and POS and POS less than count. If this is a condition, then we can go for a deletion in between two elements. So q equal to head, q equal to head. Then for I equal to 0, I less than I equal to 0, I less than position minus 1, I plus plus. I don't sure whether this for loop works. So what I am doing is I am trying to verify this one. Okay, q equal to q tends to next. Okay. Initially assigning the initially we have q equal to 100. Okay, q equal to 100. Then I equal to 0. 0 less than position. For example, the position here, this is the first position, this is the second one, this is the third one, this is the fourth one. Consider we are going to delete the third element, that is a 30. So position equal to 3. So position equal to 3. I equal to 0. So I am writing the value for position also, so that we will not get confused in between. Position equal to 3. So 0 less than 3 minus 1, 2. 0 less than 2, condition true. If the condition is true, then q is assigned as q tends to next. So q equal to 200. Okay. Now, okay, parallelly I am writing the value of I also. I equal to initially I equal to 0, comma. After this statement, after the execution, I is incremented by 1, so I equal to 1. 1 less than position minus 1. Position minus 1. 1 less than 2. 1 less than 2. Condition true. Q equal to q tends to next 200 tends to next, what is that? 200 tends to next 300. But our intention is we have to reach up to 200, then only we can do all the operation. If we reach 300, then we can complete the operation, so we have to reduce one execution from the loop. So I am reassigning the value, redefining the value of I equal to 1. So we are starting from 1. Okay, I equal to 1. Now initially the q value equal to 100. For I equal to 1, I less than position equal to 3 minus 1, 1 less than 2, condition true. So condition is true, q is equal to 100 tends to next, that is 200. Then I is incremented by 1, I equal to 2, 2 less than 3 minus 1, 2, condition false, 2 less than 2, that's the meaning. I equal to 2, position equal to 3, 2 less than, position is 3 minus 1, 2, 2 less than 2, condition false. That means q reached the second position. So once we reached here, what's next? We are going to write the remaining program. What should be there? Okay, we are going to delete 30. So what we are going to do is we are going to rename this, reassign the value of the address field of 20 to 400. So that means 300 will be replaced with 400, but 400 is available where in this position. So for deletion, I am using p to store that element q tends to next. So I am assigning the value of p here. Now p equal to q tends to next, that is what? 200 tends to next. What is that? 200 tends to next, that is 300. So the element that we are going to delete is represented by the variable p. So p is now in the exact location. So p is just for making the address free. Okay, nothing more than that. Okay, very simple. What is next? Q tends to next equal to what? Q tends to next equal to, I can simply say that p tends to next what? Why? Because I assigned here p, I am using p again here. Q tends to next equal to p tends to next. So what's happening? Q tends to next is what? 200 tends to next is this position equal to 300 tends to next, that is 400. So what's happening here is this connection get lost and a new connection is created from this location to the last location. Okay, something like this. Okay. Okay. Now, after the execution of that particular statement, this kind of link is created in between these two. After that, what we are going to do is we have to make the address free of p. That means this address 300 is getting free. After that, count is decremented by 1. Okay, deletion completed. So all the deletion process is over. So what you are going to do is you are going to write a program for this. So after the execution of this particular statement, this node is get deleted and this address is also vanished from the list. Clear? So deletion is over. What you are going to do is you are going to write a program for this, that is a structured program. This is not a structured program because I explained it for explaining you how the deletion is happening in between and in the beginning and in the last. So complete the program by yourself. Thank you.